So please pay particular attention to that. Like I said before, I repeat, these two, if the pressure that you find using this method, this pressure that you find using the PI method is greater than the saturation pressure of the gas, take the saturation pressure as the pressure to put there. So to find the mass of the water that has remained in here, which is the mass of the gas that hasn't condensed, what we do is we use the same formula, but then we use the saturation pressure. So what we now say is, using this, Mi is equal to Pi times V over Ri times T, which is equal to the pressure 4.47 times 1 over R, which is 0.4615 times T, which is 300 Kelvin. So we're just going to punch that into the calculator and see what it gives us. So 4.47 divided by 0.4615 times 300, which will give us 0.0322, 0.0328, which is equal to 0.0323 kgs. So we still have 0.03 kgs of water in here, and the one which has been, the water that has condensed, is equal to 0.2 minus 0.0323, which is equal to 0.2 minus the answer, which is giving us 0.1677 kgs. So this is the amount of water that has condensed, 0.2 minus 0.0323, which is equal to 0.1677 kgs. Then I also want you to focus, to also show you another method for finding, which I forgot, Yi. So Yi can also be equal to, now that you have seen the partial pressure this side, Pi over P total. So which is the partial pressure over the total pressure. So if we had to go this side, we can say the total pressure is the total pressure here, the summation, and then the partial pressure is one of them. So let's say if you want to find the Y of water, which is the, so we say Yi of water, which is the molar mass of water, which is the molar fraction of water, will be equal to 4.47 over 12.37 plus 4.47 plus 44.52, 44.52, which is equal to, so we get 4.47 over 12.37 plus 4.47 plus 44.52, which will be equal to 0.728. So this will be the mole fraction of water using this method of the partial pressure. Okay, so now we're going to look at some formulas which you're supposed to know for the gas mixtures, ideal gas mixtures.